Since the beginning of space exploration, the exploration of Mercury seems to have played a minor role. It simply has not been a primary focus of many space programs. However, the reason for it isn't a lack of interest in the planet itself, but rather how difficult of a planet Mercury is to explore. To put things into perspective, a total of 9 space probes have been able to study Jupiter, a planet that, at the closest, is 588 million kilometers or 365 million miles away from Earth. By contrast, only 2 such space probes have been successfully sent out to study Mercury, a planet that, on average, is 77 million kilometers away from Earth, which equals 48 million miles. This means that Mercury is more than 10 times closer to us than Jupiter, and yet it remains one of the least explored planets of our solar system. But why is Mercury so difficult to observe and explore? There are 3 main reasons for this. First, unlike other planets such as Venus, Mars, or Jupiter, Mercury is ostensibly hard to observe from Earth, and this is due to how close it is to the Sun. We know that the best time for looking at celestial objects is during the night. However, Mercury sets and rises in the sky almost at the same time as the Sun does. That means it can only be spotted for a brief period of time before sunrise and again just after sunset, and it always appears close to the horizon. Technically, the planet can also be observed with telescopes during the daytime, but astronomers need to be extra cautious not to damage the optics with the intense sunlight. For this same reason, many larger telescopes are not allowed to look into the direction of the Sun at all, and interestingly enough, it is also the reason why the Hubble Space Telescope has never taken an image of nor looked at Mercury. The second reason why Mercury is so hard to explore is how hard it is to get to the planet itself. While Mars and Venus received their first orbiters back in the 70s and Jupiter got his in 1995, it took until 2011 for the first man-made satellite to enter Mercury's orbit. And the reason behind it, once again, is the Sun, more specifically, the huge gravitational pull it exerts on the planet. So any spacecraft aiming to enter into orbit around the planet has to constantly brake against the gravitational pull of the star. This is why, according to some estimates, it would take less energy to get to Pluto than it takes to get to Mercury. Now, astrophysicists have found a smart way to accomplish this braking without needing to carry around an absurd amount of fuel, and it consists in sending the spacecraft in a trajectory that will perform multiple flybys or gravity assist maneuvers with the Earth, Venus, and Mercury itself until it enters into the final destination orbit. This is exactly what the Bepi-Colombo mission, which will part the next 2 orbiters in the planet's orbit by 2025, will do. In fact, the spacecraft will get a total of 9 gravity assists on its journey. 1 from the Earth, 1 from Venus, and 7 from Mercury itself until it reaches its final position. Overall, this is a quite cost-effective way of carrying out the mission, since the spacecraft will use its fuel mainly to get into the correct position when doing a flyby, so as to get the maximum energy out of it. However, there is also a big downside to this approach, which is how long it takes to complete the journey. The latest Bepi-Colombo mission was launched back in 2018, and it will take a total of 7 years for the spacecraft to reach its destination, which is a long time, especially considering that the mission isn't expected to last longer than a year, given the harsh conditions that being so close to the Sun pose. And this leads me to the third and final reason why it is so hard to get to Mercury. It is simply too hot. The sunlight about Mercury is about 10 times more intense than near Earth, plus the scorched surface of the planet also radiates heat back into space. As a result, anything orbiting around Mercury will have to endure temperatures upwards of 400 degrees Celsius. For reference, standard solar arrays start falling apart at 140 degrees Celsius. So this extreme temperature meant that the spacecraft sent on the previous 2 missions Mariner 10 and Messenger had to be placed into huge elliptical orbits around the planet so they could cool down after each approach to the surface. This also meant that the close approaches were very brief, which means that the orbiters didn't have enough time to obtain any high-resolution data over the entire surface of the planet. Luckily for all of us, the new Bepi-Colombo mission will be able to fix this problem due to many innovations made to its equipment, such as improved solar panels that are able to work at higher temperatures, cooling pipes that transport heat from within the radiators attached to its shaded side, and dozens of insulation blankets that cover these same radiators and help keep the sensitive instruments inside the spacecraft at room temperature. Now that you know why it is so difficult to learn anything about Mercury, it may come as no surprise that, out of the 4 rocky planets in the inner solar system, this is the one that has been least explored. With that, I want to thank you for being there once again. I hope you enjoyed the video and could learn new things. I will see you soon in the next one. Have a nice day. Take care. Bye bye.